Okay, so we're given tangent of t is 1/6 and t is in quadrant 3, and it wants us to find the values of these 6 trigonometric functions. Sine, cosine, tangent, cosecant, secant, and cotangent. Well, of course, we already know tangent. Tangent is 1/6. If I know tangent, which other one do I know with only a bare minimal amount of work? Cotangent. How do I find cotangent? Simply flip it over. So cotangent is 6/1, which is 6. All right, so that was the easy one. Now what? Math. That's right. Any ideas? Okay, so we do know that that tangent is sine over cosine. So it's tempting to do that. I agree. Tangent t is sine t over cosine t. So it's tempting to say that sine t is 1 and cosine t is 6, except you'd have to deal with some pluses and minuses to be in the right quadrant. But that can't possibly be right. Cosine t can't possibly be the number 6. Why not? What's the biggest possible answer for cosine? The biggest possible value for cosine is 1, because cosine comes from the unit circle. The x values in the unit circle go from -1 to 1. So what happened was tangent was sine over cosine, but it didn't start out as 1/6. It started out as some other number, and they simplified the fraction down. So cosine isn't 6, unfortunately. Yeah. Okay, so yeah, a brief reminder of where we left off. If we have our unit circle, this is x squared plus y squared equals 1. If we had an arc length, t, there's t, and we picked this point, x comma y, then we said our definition was cosine t is which one? Is cosine x or is cosine y? Cosine is x, and sine of t would be y. And then you're absolutely right. Since cosine of t is x and sine of t is y, I can plug those into this equation, and I can write cosine squared x, or cosine squared t, I mean, plus sine squared t equals 1. And that's one of the most important equations in all of trigonometry. And this is called the Pythagorean identity. Why is it called the Pythagorean identity? Because it actually comes from the Pythagorean theorem. And we'll see it again when we talk about triangles. We will talk about triangles yet. Okay, so now I'm going to take this equation, cosine squared t plus sine squared t equals 1, and I'm going to divide everything by cosine squared t. What's cosine squared t divided by cosine squared t? 1. What's sine squared t divided by cosine squared t? Tangent squared, because sine divided by cosine, that was our definition of tangent. So this is tangent squared t. And how about this one? Back on Friday, what was 1 divided by regular old cosine was secant. So 1 divided by cosine squared is going to be secant squared t. All right, so this gives us an alternative form of the Pythagorean identity. This is still called Pythagorean identity. 1 plus tangent squared equals secant squared. I could have done the exact same thing. Instead of dividing by cosine squared, I could have divided by sine squared. If I had divided everything by sine squared instead, I would have had cotangent squared t plus 1 equals cosecant squared t. So those 3 are known as the Pythagorean identity. There's kind of three of them, but they're all called one because they're really all the same. All right, so now we're ready to go back and answer this question. If I know tangent is 1/6, I'm going to take 1/6 and plug it into this formula right here. And what's that going to allow me to do? It'll allow me to find secant. Once I know secant, I can find cosecant and cosine and sine. Once I know that one, I can find the other ones. All right, so that's what we need to do. So we're going to have 1 plus 1/6 squared equals secant squared t. So that's 1 plus 1 over 36 equals secant squared t. What's 1 plus 1 over 36? 37 over 36 equals secant squared t. And then I have to do square roots on both sides. And when I get a square root, I get a positive answer and a negative answer. For this problem, which answer do I want? Do I want the positive one or the negative one? And why do you say you want the negative one? Because way back in the beginning, it told us we were in quadrant 3. And if we're in quadrant 3, secant is negative. All right, so secant of t is square root of 37 over 6. I do square root on bottom. The square root of 36 is a nice number. It's just 6. So I would leave it that way. All right, so I can go up here, and I can fill in secant is square root of 37 over 6. Now that I know secant, which one can I find without doing much work at all? Cosine. How do I find cosine? Flip it. So if I know secant is square root of 37 over 6, cosine is 6 over square root of 37. All right, finally, how do I now find sine and cosecant? Do what? Which other formula? I have two choices. Option number 1 is I could use this one. Option number 2 is now that I know cosine, I could actually use this one. If I had to pick, I would choose using this one. And the reason is this cosine and the secant were things that I had to do quite a bit of work to figure out. In fact, now that I look at it, I wrote wrong answers. They should be negative. Should both be negative, that's wrong. What I want to do is I want to use the formula that I had to do the least amount of work to be able to use. So I think I would use this formula because figuring out this cotangent was pretty easy. I'm really, really confident I didn't make any mistakes there. If I made a mistake in figuring out this cosine and then I use that to figure out the sine, of course, it's going to be wrong too. So I personally try to use the formula that I've had to do the least amount of work to get to. So my choice would be I would use this formula. So I know cotangent is 6. So I would have 6 squared plus 1 equals cosecant squared. So 36 plus 1 is 37 equals cosecant squared. I'm having trouble writing cosecant today. So cosecant, I keep wanting to write cosine, is negative square root of 37. And again, it's negative because I'm in quadrant 3. So negative square root of 37. And so finally, the sine is, flip it, negative 1 over square root of 37. Slide it up, slide it down. How about I zoom out a little bit? Maybe it's all the way zoomed out. Maybe it don't fit in one screen. Still doesn't all quite fit in one screen. Okay. Other questions concerning homework? Or questions on anything else? The meaning of life, I believe the answer is 42. Other questions? All right, so as I recall, on Friday, we had this sheet that we were working on, and we finished problem 3, as I recall. All right, so problem 4. Problem 4 should be a quick one. If sine is positive, but tangent is negative, which quadrant does that have to be? I hear a vote for 2 and I see a vote for 4. So sine is positive in which quadrants? 1 and? Everything's positive in 1. Sine is positive in 1 and 2. Where's tangent negative? 2 and 4. So this one has to be 1 or 2. This one has to be 2 or 4. Where do they overlap? 2. This one's 1 and 2. So remember we had our little chart. Albany State Teachers College. All suckers take calculus was another version we heard. All things are positive. Sine is positive. Tangent, cosine. All right, so now we have secant is negative. So where is secant negative? Secant goes with cosine. Where's cosine negative? Cosine's positive in 4. So secant is positive in 4. So 2 and 3. So this one's 2 and 3. Where is cosecant negative? 3 and 4, because cosecant goes with sine. Sine is negative in 3 and 4. So this one's 2 and 3. This one's 3 and 4. Putting them together, that one has to be 3. All right, these last two problems. This is very, very similar to what we just did a minute ago from the homework question. It says, determine the value of the 6 trig functions. Cosine is negative 3/8, and sine is positive. All right, in the homework problem we did, it specifically told us which quadrant we were in. In this problem, the first thing we need to do is figure out which quadrant we're in. Well, if cosine is negative and sine is positive, what quadrant is that? That's quadrant 2. Okay, so write down my answers here. Cosine t, sine t, tangent t, secant t, cosecant t, and cotangent t. And the one we know without doing any work is cosine. Cosine is negative 3/8. Which one's easy? Secant is negative 8/3. You just flip it. Okay. What's next? Pythagorean identity. So in this case, I think we want to use, it's usually written as sine squared plus cosine squared equals 1.
We have to memorize this.
The Pythagorean identity is one you should memorize, absolutely. Sine squared plus cosine squared is 1. We will use that a lot. So that's one you should absolutely know. Plug in my numbers. Sine squared t plus negative 3/8 squared equals 1. So sine squared t plus 9/64 equals 1. So sine squared t equals, what's 1 minus 9/64? 55 over 64, very good. Is there absolutely anything preventing you from using your calculator right there to do those fractions? No? Do I encourage you to use your calculator to do those fractions? Yes. I do not care if you can add, subtract fractions in your head anymore. Use your calculator. Square root both sides. Sine t is square root of 55 over 8. Do I want the positive square root or the negative square root? Positive, because we decided we were in quadrant 2, and it said right from the beginning, sine is a positive number. So we want the positive square root. So that's going to be square root of 55 over 8, which means cosecant is 8 over square root of 55. All right, 2/3 done. I got 4 out of 6 completed. What's next? Tangent. How do I find tangent now? I can just use sine over cosine in this case, right? So tangent is going to be sine, we decided was square root of 55 over 8, divided by negative 3/8. I'm going to take the bottom, the negative 3/8, I'm going to flip and multiply. When I flip and multiply, the 8s are going to reduce out. I'm going to be left with negative square root of 55 over 3. And if you don't believe me, write it out. Flip the negative 3/8, reduce your fractions, that's what you get. And finally, cotangent, just flip it, so negative 3 over square root of 55. Questions on that one? All right, I'm going to skip B. B, it's practically the exact same problem we did here, just with a different number. So follow along with what we did there, and B is really the same. All right, I think we're ready to move on to section 5.3. In section 5.3, we're going to talk about graphing sine t and cosine t. But before we do that, I want to do a little bit of review of something you learned last semester. Let's say I gave you the function f of x equals absolute value of x. The graph of that function looks a lot like that. This is the point 2, 2. This is the point negative 2, 2. And of course, it's right there at 0, 0. What if I asked you to graph g of x equals absolute value of x plus 3? What does that plus 3 do to the original graph? Raises it up 3 points. That's exactly correct. So it would now go through the point 0, 3, and this would be 2, 5, and negative 2, 5. So when I put a number outside of the parentheses here, it moves it up or down. Positive is up, and negative would be down. All right, what if I asked you to graph h of x equals absolute value of x minus 2? What happens when I put the shifts to the right? So when I put a number inside the brackets like this, it moves it left and right. But what you saw last semester is left and right goes backward. Your first guess would probably be a minus sign is going to move it to the left, but you actually saw a minus sign inside the brackets moves it to the right. Okay. So it's now going to look like this, where this is 2, 0. This would be 4, 2. I add 2 to all my x numbers, 0, 2. finally, hij j of x is 1/2 absolute value of x. What if I multiply by a number like that? What does that do? Gets narrower? Thinner?
No, it goes wider because it's a fraction of the older version. It goes wider because it's partially the fraction.
Ask the calculator. All right, that's a good answer too. What this does is this takes, remember this is our original y right here. This thing was our original y way back at the beginning. So I'm taking all my y numbers and I'm multiplying by 1/2. So instead of having the point 2, 2, I'm going to have the point 2, 1. So it's definitely going to make the graph flatter. It's really not, people like to say it makes it skinnier, it makes it wide. What it's really doing is it's up here and it's squishing it down. It's actually making it less tall. And if this were a number like 3, I would be grabbing the ends and yanking them upward, which kind of makes it look skinnier, but that's really not what's happening. It's really affecting wideness. All right, so anyway, this one would look like this. It would not be as tall. And I would still have 0, 0, but now I would have 2, 1 and -2, 1. All right, so there was a name for all these things in the graph, up, down, left and right, making it skinny, making it fat. What was the name for that? This is called translations. All right, so what we're going to do today is we're going to figure out what a standard sine wave should look like and what a standard cosine wave should look like. And then we'll use translations to move it around and get different graphs. So that's why I wanted to do a quick review of translations first. Okay, so let's graph y equals sine t. Calling it y wasn't a very smart choice. Oh well, I'll live with it, I guess. Because I really want to think about when I pick a point on this circle right here, what's the x value? Is it cosine or sine? X is cosine and y is sine. Okay, so on this axis here, I'm going to have the t values. So I'm going to have, here's pi, here's 2 pi. You remember this, good. Pi over 2, pi over 4, 3 pi over 2, so on and so forth. Okay, now what can you tell me about this? If I start at t equals 0, if t equals 0, what's the sine value right there? Sine of 0 is 0, because that's the y value. Sine of 0 is 0. What if I jump all the way to pi over 2? Sine of pi over 2 is? What's the y value right there? Is it 0, 1? So y is 1. So sine of pi over 2 would be 1. What happens in the middle? What happens in the middle here of quadrant 1? Like if I were to pick pi over 4. What's the sine of pi over 4? That one's not the 1/2 one. I skipped one in the middle there. Sine of pi over 4 is square root of 2 over 2. So sine of pi over 4 would be right about here, square root of 2 over 2. Now we'll go back to this one. What about sine of pi over 6? Pi over 6 would come before pi over 4. No. 1/2. And then how about pi over 3? Pi over 3 is about here. What's the y value right there? At pi over 3? Square root of 3 over 2. So between 0 and pi over 2, I get this kind of curve like so. Sine of 0 was 0, sine of pi over 2 was 1, and my y values kept getting bigger. What's going to happen when I use my angles in quadrant 2, when I pick all the angles that have these angles as quadrant 1 as reference angles? What's going to happen to my y numbers here? These y numbers are going to go down, aren't they? So this one's going to be square root of 3 over 2. This one's going to be square root of 2 over 2. This one's going to be a half, and this one's going to be 0. So when I get over here to pi, my y numbers are going to have come back down. Like so. What happens when I keep going and I pick like 7 pi over 6, 5 pi over 4, 2 pi over 3. Do the same values. I'm going to get the 1/2, the square root of 2 over 2, square root of 3 over 2, except they're all going to be negative. And when I get all the way to 3 pi over 2, the sign at 3 pi over 2 is negative 1. So my graph's going to come down here to negative 1. And then finally, what happens in quadrant 4? What can you tell me about my y numbers? They go back up. What happens if I keep going? So I've gone all the way from 0 to pi over 2. What if I keep going? What if I go bigger than pi, or I'm sorry, 0 to 2 pi? What happens if I go bigger than 2 pi? It just repeats, doesn't it? Because if I go bigger than 2 pi, I'm going to hit this one and this one and this one. So it keeps going. So we say that the sine graph has what we call a period of 2 pi. What that means is you get one complete cycle in a length of 2 pi, and then it would repeat. If I went 2 more pi, I'd get the same graph. If I went 2 more pi, I'd get the same picture over and over and over again. Questions on that? All right, so that's what the sine graph looks like. What about the cosine graph? Define opposite. Cosine is the x numbers. So cosine starts at 1. So my angle is 0. My x is 1. And then here's pi and 2 pi. Now, as I go in quadrant 1, here's pi over 2 and 3 pi over 2. As I go in quadrant 1 and I go around the circle here, what's happening to the x numbers? They get smaller, don't they? At pi over 6, we get square root of 3 over 2. At pi over 4, we get square root of 2 over 2. At pi over 3, we get a half, and then we get down to 0. So my x numbers get smaller, which means my graph is going to look like that. What happens to my x numbers when I move into quadrant 2? Well, I'm already at 0 right here. They go to negative numbers, don't they? The x value right here, I'm to the left, this has a negative x value. So this is negative a half, negative square root of 2 over 2, negative square root of 3 over 2, and here we get all the way to x is negative 1. So it keeps going down till we get down to a low point of negative 1. And then it's still negative in quadrant 3. X's are still negative. And then x's turn back to positive in quadrant 4. So we get a picture that looks like that. And then, of course, it keeps going. So in reality, the sine wave and the cosine wave are really exactly the same. It's just, if I take the sine wave and shift it over pi over 2, it starts right there, and I would have the cosine wave.
What are your thoughts on using tau over pi?
Tau instead of the little pi?
Yeah.
Why would you want to use tau instead of pi, I guess would be my question.
Isn't tau just 2 pi, right?
No, I don't think so.
I thought that's what it was.
Tau is the Greek letter T. We write our T's like this. The letter tau is usually written that way. It's kind of like, this is the Greek letter for P, but it's pronounced pi. That's all. I would prefer that you write 2 pi. You don't know your Greek?
No.
Oh, you should go see Mr. Bikert. He'd teach you all about it. He'd be happy to teach you. Okay, so anyway, there's our standard sine wave and our standard cosine wave. Notice our cosine wave is also 2 pi periodic. It goes through one complete cycle in a distance of pi, or in a distance of 2 pi, I mean, and then it repeats over and over again after that. So we have words that we use. Period is 2 pi. Now you can. Another word we use when we're dealing with trig graphs is amplitude. A-M-P-L-I-T-U-D-E. What's amplitude mean? Anybody remember? It's the height from, well, not always 0 because sometimes we shift the graphs up or down. But it's the height. So in this case, it's the height from your midpoint to your high point. So in this case, the amplitude is 1. And same here, the distance from our midpoint to our high point is 1. So we would say the sine wave and the cosine wave have amplitude 1. And then another word you're going to hear is frequency. Neither, unfortunately.
So to find the amplitude, isn't it the period over the frequency? Is that?
No.
No, okay.
You're close though. The frequency is 1 over the period. There's the relationship between these two. So in this case, we would say the frequency is 1 over 2 pi. Where have you heard the word frequency before? Physics. And what do we use frequency for in physics? Sound waves is where it's most commonly used. So you might hear a certain tone has a frequency of 60 hertz. Something like that. So what they're really doing is they're saying 1 over 60 is the period. They're kind of giving you the period in a different format. All right. What if... some other things I wanted to talk about. Back in Math 1411, you should have talked about even and odd functions. What do you remember about even and odd functions? Anything? What's that? Okay, if you're dealing with polynomials, it was very easy to talk about even and odd functions. What was an even function if you had a polynomial? All the powers were even, like x squared plus x to the 4th would be an even function. And what were odd functions? The opposite, all the powers were odds. That's correct. When you graph even and odd functions, there was a property. All right, so when you have an odd function, you can take it and turn it upside down, and you have exactly the same picture. If I take the sine wave and turn it upside down, I've got exactly the same picture, don't I? So we called that symmetric with respect to the, not the x-axis, origin, rotational symmetry. So sine is an odd function. Another way of saying that is sine of negative t equals negative sine of t. That was your formal definition of odd functions. The formal definition of an odd function was it takes a negative sign and pulls it out to the front. Now how about even functions? What did even functions look like in a graph? Mirror image with where? Not the origin. Not the x-axis. The y-axis, that's correct. So, if I were to take this cosine graph, if I could take this paper and fold it right on the y-axis, what would happen? It would match up. So the cosine function is an even function, and the formal definition of even means that cosine will take negative signs in here and it will simply kill them. Cosine of negative t is exactly the same as cosine t. For example, I'll give you some examples of these things. What's the cosine of pi over 4? Square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. What if I put a negative pi over 4? Where is negative pi over 4? Which quadrant? It's in quadrant 4, isn't it? And cosine is positive or negative in quadrant 4? Positive. So it doesn't matter if I put a minus sign in here or not, I get square root of 2 over 2 both times. Cosine kills negative signs. On the other hand, sine does not. If I asked you for sine of negative pi over 4, we would be in quadrant number 4, so is our answer going to be positive or negative? It would be negative because we're in quadrant 4. So I would get negative square root of 2 over 2. That means sine is an odd function. All right, I have just about time for one more thing today. So, now we're ready to talk about translations a little bit, and we'll talk about translations a lot more on Wednesday. What happens if I take my sine and I put a 3 in front of it?
It would become this kind of little word.
Okay, so there's my usual standard graph. There's y equals sine t. It stops right here at 2 pi. One complete cycle happens within 2 pi. It has a maximum height of 1 and a minimum height of negative 1. So this is pi right here. What does that 3 do? Does what? Multiplies what? It multiplies the whole thing by 3. So instead of having the point 0, 0, if I multiply everything by 3, I'm going to have 0, 0. 0 times 3 is still 0. Instead of having this point right here, this is the point pi over 2 comma 1, what am I going to have? It doesn't multiply both the x and the y. It only multiplies one of them. It's pi over 2 comma 3. It's just like this one that we did a few minutes ago. When I put this 1/2 here, it only changed the y numbers, not the x numbers. So if I put a 3 out front here, what it's going to do is it's going to make the graph go 3 times higher right there. And 3 times lower right here. Absolutely. What's going to happen at this point? The y value is going to stay the same because 0 times 3 is still 0. And this point is going to stay the same too. So, what did multiplying by that 3 change? Did it change the period? Did it change the frequency? Did it change the amplitude? It changed the amplitude. So multiplying by a number here out front is going to make the graph either a lot taller, or what if I had to put a 1/3 there? It would make the graph shorter. All right, so this number right here, we usually write y equals a sine t. Absolute value of a will give the amplitude. Amplitude is always given as a positive number. This could have been a -3. What would it do if it were a -3? Same thing plus something else.
It would have reflected across the line.
It would have reflected across the x-axis. Because I would have been multiplying all my y numbers by -3. So instead of having a 1 here, I would have had a -3 way down here. Instead of having a -1 here, I would have multiplied by -3. So if I had a -3, it would have done two things. It would have flipped it, but it still would have changed the amplitude. But amplitude is always given as a positive number. So if this is a -3 here, my amplitude is still going to be given as a +3.